Section 11.1 talks about basic notions. So chapter 11, y'all, is going to be on geometry, okay? So we have points A, B, and C, and you can see our points here. Let's see, we have a line L, and it's the center of the road. And then we also have what we call line M, line AB, and there's a few ways that they write it, okay? So when we say line AB, A and B are 2 points on that line, okay? Another way we can write it is like this, AB, and this little symbol here indicates that it's a line. Remember, a line goes on in both directions infinitely, and line AB is the same thing as line BA, okay? So we don't really have a start point or an end point, so those two are points on our line. Okay, then we have something called a plane, and like the surface of this desk or this table is our plane. That's the Greek letter alpha. And then we also have another way to write it, plane ABC, or it looks kind of like an upside down Y, or it looks kind of like a funny Y. This here, guys, is the Greek letter gamma, and this one here is alpha. Okay, so it says a line is uniquely determined by 2 points, that is, given 2 distinct points, there is one and only one line that contains these points. A basic concept in geometry is that of distance. If P and Q are any distinct points, then we create the number line PQ, such that there's a one-to-one correspondence between the points on that line and real numbers. Moreover, if P corresponds to the real number 0 and Q corresponds to a non-negative real number, the distance between P and Q, written PQ, is the real number that corresponds to Q. Okay, so let me explain what that part means. So here is my number line, right? And look what it says. If P corresponds to the real number 0, so here's 0, and we're going to call this, we're going to call this point P. And then it says if Q corresponds to a non-negative real number. Non-negative means it's going to be either 0 or bigger. So it means to be somewhere being positive, okay? So, let me get my pen again. Froze up on me. Let's see. There we go. Okay, so this here is Q. Then it's saying that the distance between these 2 points here is going to be whatever that number is. And think about the distance. The way we find the distance is we take this number, the number Q, minus the number P. But we know that the number P is 0. So Q minus 0 would just be Q. Okay. All right, let's see. What else do we have here? We have something called collinear points. Collinear points, guys, mean that they are on the same line. Okay. So line L corresponds to the points A, B, C. Okay. Points A, B, C belong to the line L. You can see they're all in the same line, all right? A, B, C are collinear. Points A, B, and D are not collinear or non-collinear. And you might say, why is D non-collinear? Look where D is. D is below that line, okay? All right, let's see. It says if A, B, and C are 3 distinct collinear points, then B is between A and C if and only if A plus or AB plus BC equals AC. So you can see that this piece here plus this piece here is going to be the same thing as from here to there, right? Okay. All right. Let's see. What else do we got here? We have something called a line segment. Okay, so a line segment or a closed segment is a subset of the line that contains 2 points on the line and all points in between. So this is our line segment, okay, and we have endpoints, okay? We have a starting point and we have an ending point, okay? And we can call that line segment AB or we can call that line segment BA, just depends on how we're looking at it. Let's see, what else do we have? We have subsets, okay? We have a half open or a half closed line segment. What I want you to notice here, do you see how the point around the A is open, meaning it's kind of filled in, it's like this, and then this part is filled in. So when we have something like this is what we call half open, right? And it's half open because one of those endpoints is filled in and the other one isn't. Or sometimes they call it half closed. And then the open segment, if you notice here, both of those endpoints are, both of those endpoints are open, okay? Let's see, what's the next thing? The next thing here says array. Array AB is a subset of the line AB that contains an endpoint A and a point B, and all points between A and B. So again, if you notice here, this one here, we have a starting point, A. We have another point on that array B, but that thing keeps going on forever and ever and ever, okay? Let's see. A half line is a array without an endpoint. So again, if you notice here, it's sort of open, and then it goes on forever, right? So B, and there's another one there, C. Okay, so let's talk a little bit about these things. All right. So the directions here say name two rays that contain the following line segments. All right, the first one here says TU. So here's my line segment TU. Okay, we got our endpoint, two endpoints there, okay? So we're going to look for those two. Okay, so let's look first at UZ. Well, UZ goes that direction, so I know that's not what I want. S, X, S, and X, not even on the same line. I know I don't want that one. Look at WU. Okay, so let me get my red pen. WU starts here, and it keeps going. Oh, yeah, that's one that we want. Clicks right off it. Y and V, nope. And T and U. Okay, so let me clean this up. T and U starts right here, and it keeps going. Yes, that's the other one that we want. Okay. Alrighty. Okay, so now look at YZ. Okay, so let's do YZ. Let me go with red here. So here's Y, here's Z. We're looking for something that's going to be on this line here. Okay, so let's take a look. Would XT work? XT, no. Would YZ work? YZ would start here and keep going. Yes, that would. So let me click this one. XZ, X would start here and keep going that way. Yes, that one would work also. S and Y, no. And Z and U going that direction, going this direction, no, we don't want that one either, right? Okay, so we found the two rays that contain those line segments. All right. Okay, so now we're going to talk about coplanar points. So it says coplanar points are points on the same plane. So look what it tells us here. It says points D, E, and G. So D, E, and G, they're all on kind of that peach-colored plane, right? D, E, G, and F are non-coplanar. Why is that? Because F is sort of hovering above, right? F is above that thing. Let's see. Coplanar lines are lines that are in the same plane. So let me just clean up some of this mess here so we can figure out what that is. Okay, line DE. So here's line DE. Line DF. Let's see, line DF. Up there. And FE. This line here are coplanar. Line DE, this one here, DG, and EG are coplanar. Okay. Let's see, there we go. Let me erase this mess now. Let's see, it says skew lines. Lines that cannot be contained in a single plane are coplanars. So GF, let's see, where's GF? GF is this line right here, okay? And DE are skew lines, okay? Those are skew lines because they are not in, they're not in the same plane, okay? Let's see, DE, so let me get my green pen, DE, here's DE, excuse me, and GE are intersecting lines. They intersect at this point. And let me clean up this mess now. Okay, and it says line DE. So here's DE, EG, and EF are what we call concurrent because they intersect at a single point. They all intersect at that point E. Okay. All right. Let's see. Two distinct coplanar lines are parallel if they have no point in common. So these here would be parallel lines, right? And let's see. It says two distinct intersecting planes have a single line in common. Okay, so here is my plane alpha, right? That's alpha again, in case you're wondering. This one here looks like a funny looking B. That's beta. Okay. And so those two planes, this is a little symbol for intersection. They intersect at that line right there, right? That line AB. Okay. So we're going to get to some problems in a minute, guys. We just kind of have to go through some of this stuff here. It says two planes are parallel if they have a single line in common or all points in common. Okay. Let's see. A line and a plane are parallel if their intersection is the empty set. That means that they do not intersect. Okay. And a line contained in a plane separates a plane into three mutually disjoint sets, two planes and the line itself. And a half plane is a subset of the plane that contains all the points in the plane on one side of the line. Okay, so now let's see if we can figure out this problem here. We're going to do it slowly so that we kind of get an idea. It says the figure below is a rectangular box in which EFGH and ABCD are rectangles. BF is perpendicular to the planes EFG and ABC. Use the figure to complete parts A through E. Okay, so guys, just a little symbol. When you have something that looks like this and you see these little squares here, it just means that these things here are 90 degrees, and 90 degrees is the same thing as what we call perpendicular. Okay. All right. So part A says, which pair of lines are skew lines? Okay, so skew lines, guys, are going to be in different planes, okay? Different planes. So let's take a look at the first one, AB. So it's this line right here, and then it says line BC. Well, no, those are not in different planes because they're all in this sort of top part of that rectangle, okay? So I know that the first one is not my choice. Now, let's take a look again. Look at part B. It says line AB, okay, right here, and line FH. Okay, so do you see how those two lines are in two different planes? The first line, guys, again, is in this top plane, and the second line is actually in that bottom plane. So far, B appears to be my answer, okay? But we're going to go through each of the choices so that we understand why, okay? Look at part C. It says CG and DH. CG, okay, where's CG? Okay, here's CG, it's right, let me go back with red. CG is right here, and DH is right here, and no, those are parallel lines because they're in that same plane, right? They don't intersect, so I know that's not what I'm looking for. We're looking for skew lines, right? Skew lines, different planes, okay, so let me just write that here. Skew lines are in different planes. Okay. And then finally it says FH, so where's FH? This one down here. And FG, no, they're in the same plane and they intersect at that point. Okay, so we don't want that one. So again, just so we understand why, AB was this line here, right? And FH was this line down here. And so those two lines are in different planes, right? And that's why we chose B. Okay. Alrighty. Now let's get to the second part of the question. Part B says the intersection of planes EAB. Okay, so let's see if we can find the plane EAB. EAB. Okay, EAB is going to be sort of that left side right there. And the plane BDH. Okay, so let's go to find, let me get my pen going again. Oh, come on. Sorry about this, guys. There we go. Okay, and then plane BDH. So here is B, here's D, Here's H. So sort of that middle piece there, right? Where do those two planes intersect? They intersect right here, don't they? At whatever that line is. So I'm going to erase that just so I can see what the letters are, because I can't see it from here. So I'm going to erase all this, and it looks like it's the line BF, which is this one right here. So guys, what I did here was when you're doing your homework in my math lab and you click on this, these are going to be your options, okay? So I just kind of copied and pasted there so you could see which ones, what it would be, what it's going to look like. But in this case, BF appears to be my choice. Okay, so now part C says plane DCG in which other plane are perpendicular? Okay, so let me clean this mess up. Oh, come on, pen. There we go. Oops. Okay, so which plane are we looking at again? DCG. Okay, DCG. DCG. So it's going to be this one here, okay? So which one is also perpendicular to that, okay? So let's see. So let's see. Plane FBD. So FBD would be here, here, and here. Well, it doesn't look like those two. This would be where they're meeting, right? And that angle is not 90 degrees. So no, that's not what I'm looking for. Okay, so our plane was DCG. Okay. Let's see. What else do we have? Line DC. No, because that's in the same plane. Okay, so I don't want that. So I know this is not good. I know that's not good. Line FG. Where's line FG? Okay. Line FG is this line right here. No, again, I'm looking for something that's going to intersect it at a 90-degree angle. Okay. And plane EAB. So let's see. Plane EAB. Ah, you know what? My bad. Isn't this here 90 degrees? Right there. So this one here should be FG because plane EAB is parallel, right? And we're looking for perpendicular, okay? All right. Part D says, what is the intersection of line GH and ABC? GH and ABC. Okay, so let me scroll back up here. GH, so where is GH? GH is right here. And line GH and plane ABC. ABC. Which is sort of the top of that box. Okay, so they're asking, where do those two pieces intersect? That black line down here and this top of the box. Where do they intersect? And so if I come back over here and I look at my choices, well, we know that they don't intersect. So when they don't intersect, guys, this is what they call the empty set. Okay? No intersection. Okay? All right. So part E says, explain why planes BCG and DCG are perpendicular. Okay. So let me clean up this mess. And what were the planes again? BCG and DCG. BCG and DCG. So BCG, BCG. Okay, it's that back wall there. Okay. And the other one was DCG. DCG is sort of this side one right here. Okay. Why are they perpendicular? Remember what perpendicular means? Perpendicular means that there's going to be a 90-degree angle there, right? So if you notice, if you think about that, right, that's the back side of the box and the right side of the box, okay? Why are they perpendicular? because the intersection of the planes is a single line and planes form a right. Right is the same thing as 90 degrees, okay? Right angle. Oops. Right angle is 90 degrees. Okay? And that's what we're looking at. All right. So the next problem I have here, it says name 3 points in the diagram that are not collinear. Okay, so we're going to look for 3 points that are not collinear. Let's just look at our options. F, P, and Q. F, P, and Q. Yep, those are not collinear. Okay, so we got one. P, F, and K. P, F, and K. Yep, those are also non-collinear. Okay, so the first 2 so far work. We need to get 3 total. F, K, and Q. Okay, F, K, and Q. No, those are all on the same line, so we don't want that one. F, T, and P. Okay, F, T, and P. Yes, those are my 3, right? Okay, and if you notice, if we did F, T, and Q, look, here's F, here's T, here's Q, so we don't want that. And F, T, and K, F, T, and K again on the same line, right? Alrighty. Okay, it says the figure is a triangular pyramid. It says each triangle creating the pyramid determines one face. Use the figure to determine parts A through F. Okay, so I'm going to get my pen. The intersection of the line BE, so here's my line BE, and the line AC. Okay, and let's see, do those 2 lines intersect? So again, notice, you might look at it, you might say, oh look, they meet there, but remember, this point E is sort of in the middle. So they do not intersect, which would be the empty set, right? So again, just a little simple here, guys. This is the empty set, and it means there is no intersection, right? Okay, so let's take a look at part B. What are the intersection of the planes ABD? Okay, so ABD, which is going to be this face right here, okay, and BCD. So BCD would be BCD, would be this face here. So wouldn't you say that those 2 planes intersect at the line BD? And that would be my choice C, right? Okay. So again, let me erase this here. So guys, I want you to notice as I'm going through this, I'm drawing on my picture. I think it helps a lot when you do that, okay? Because it makes it visual and it's kind of easier for us to understand what's going on. All right, what is the following intersection of the line BE? Okay, so here is BE going straight down, and BD is going down over here to that angle. So wouldn't you say those 2 lines intersect at the point B? And that appears to be one of my choices. Okay. And then now it's asking me which pair of lines are parallel. Okay, so AB and BC, so let's come back over here and let's see. AB and BC, are those lines parallel? No, they don't, because they intersect at the point B, so we know that's not an option. Okay. Let's see, AB and AD. AB and AD, no, because they intersect right there, so those are not parallel lines, right? Parallel lines never meet. They're in the same plane. BD and BC. BD and BC, no, because they intersect right there. And so if I look at my 4th choice, it says the figure contains no parallel lines, and that would be my correct option, right? Okay, which pair of lines are skew lines? Okay, so let's take a look, see if we can find some skew lines. So it says line AD and line AD and CD. AD here and CD there. Nope, those are not skew lines. Okay, so we don't want that. CD and CB. CD and CB, no, because they intersect right there. Those are not skew lines. Remember, skew lines are going to be in, in different planes. Okay. AB and CD. AB and CD. So AB here and CD there. Yes. Let's see. AB and CD. So if I look at that, yeah, this is like one of the sides coming up here, right? Going here, and this is one of the bases. So those are going to be my skew lines right there, right? AB and CD, those are going to be my skew lines. They're in different planes, okay? And now, part F says, which of these planes is not determined by one of the triangular faces or the base of the pyramid? Okay, so the first one we have is BEA. So let me clean this up here. And let's go BEA. So BEA. Okay, so this, remember, this goes down to the middle, right? So it's sort of a little triangle that's on the inside of that triangle, okay? And inside that pyramid. It's not one of the faces, and it's not the base, right? So BEA would be my correct choice, okay? All right, so we got another question now, okay? Let me get my pen going again because it is still freezing up. There we go. It says, find a physical model for parallel lines. So guys, remember what parallel lines look like, right? They look like this. They don't intersect, okay? So ropes holding up a tent pole. So here is, let's see, ropes holding up my tent pole. No, bicycle, no. What about railroad tracks? Wouldn't railroad tracks be parallel lines? Because those two are not going to meet, okay? All right, let's see. Find a physical model for a right angle. Okay, the angle between a ground and a wheelchair ramp. So here's my wheelchair ramp. Here's the ground. No, that's not going to be 90 degrees, right? Because 90 degrees would look like this, and that's not a very good model for a wheelchair ramp. So we don't want that one. The corners in the room of your home. Okay, so here is my, here's one of the walls, right? Wouldn't these corners here be 90 degrees? So yes. Okay. Let's see. Find a physical model for parallel planes. Okay, so guys, remember what parallel planes are going to look like. They're going to look like they're planes and they're not going to intersect. Let's see. Two adjacent walls in your home. So this would be an adjacent wall and that would be an adjacent wall, but no, they're going to intersect right there. So I don't want that one. A floor in a building and a ramp between the floors. No, that's not going to be parallel because they're going to intersect. A highway and a billboard along the highway. So here's my highway, right? And here is my billboard. And no, those wouldn't be. Those would be, because those would actually be. What about, look, two opposing facing walls in your house, right? So if you're looking at your house, right? I don't think anybody's house looks like this, but I hope you're trying to get, you see what I'm trying to get to, and I didn't even draw that picture very well. There we go. That's a little bit better, maybe. But like what they're saying is this face here and that wall over there, right? So those would be the ones that I'd be looking at. Okay. All right. And it says, look at the next one. Choose the correct answer below. Parallel lines and skew lines are similar in that they're both non-coplanar. No, that's not true. Remember, parallel lines, guys, are in the same plane. Okay? Parallel lines and skew lines are similar and they do not intersect. That is true. Okay? And there's my choice. Okay? And look at part B. It says parallel lines and skew lines are different and that parallel lines and skew lines do not intersect and skew lines do. No, that's not true. Okay, so guys, just to give you an idea, again, parallel lines are in the same plane. They don't intersect. Skew lines would be one line is going like this, and the other line is sort of hovering above it, but they're not going to intersect, okay? Let's see. Parallel lines and skew lines are different in that they're not coplanar and skew lines are coplanar. No, that's not true. Parallel lines are coplanar and skew lines are not. Yes, that is my choice right there. Okay. All right. So let's talk a little bit about angles now. And it says an angle is a measurement, the amount of opening between its sides. The degree is commonly used to measure angles. A complete rotation about a point has a measure of 360 degrees, written like this. Got a little, kind of like a little zero. And it says at the top, it says 1 degree is 1/360th of a complete rotation. The measuring device pictured is called a protractor. Do we have a picture of a protractor here? No, I guess I didn't put it in. Here's my protractor. That's my protractor right there. Okay. Let's see. And it says a degree is subdivided into equal parts minutes, and each minute is further divided into 60 equal parts called seconds. So it says right here, the measurement 29 degrees, 47 minutes, 13 seconds is written like this. Okay, so this is 29 degrees, 47 minutes, 13 seconds. Okay. All right. So part A says, in figure 5, find the measure of angle BAC if the measure of angle 1 is 47.5 or 47 degrees 45 minutes and measure of angle 2 is 29 degrees 58 minutes. Okay, so we want to find the measure of angle BAC. So we're looking for this piece right here, okay? And we know that the measure of angle 1 is 47 degrees, 45 minutes. And we know the measure of angle 2 is 29 degrees, 58 minutes. Okay, so what do we need to do to find this piece right here? We got to subtract them. So we're going to take 47 degrees, 45 minutes, and we're going to subtract 29 degrees, 58 minutes. Okay? So guys, think about this like time, okay? I'm going to borrow 1 from here, and that's going to become a 46. That 1 that I'm going to borrow, suppose I'm borrowing an hour. Isn't an hour the same thing as 60 minutes? So now, this right here, this piece, is going to give me 105 minutes. And I'm just going to subtract, okay? So let me grab my calculator. Let me turn it on. Clear it. Okay, so let's go 105 minus 58. Okay, this is going to give me 47 minutes. Oops, that's not what I wanted. Sorry about that, guys. And my calculator again. And then I want 46 minus 29. Oops. Minus 29. And that's giving me 17 degrees. So 17 degrees, 47 minutes. Okay, so again, why did I have to borrow? Because I can't take away 58 when I only got 45, right? So that's why I have to borrow, okay? Let's see. So we have acute angles here. Acute angles measure less than 90 degrees. A right angle measures exactly 90 degrees. An obtuse angle is greater than 90 and less than 180, and a straight angle measures exactly 180. Okay. So let's see. The directions here for this next problem say use the protractor to find the measure of each angle. Guys, I'm going to zoom in. It's probably going to throw me off, but I'm going to zoom in because it's a little small for me to see. And let me do that one more time. And I know it's throwing me off, but it's okay. We'll come back and we'll fix it as we need to. Okay, so give me 1 second. I wish it wouldn't throw me off, but it does. go. Ah, there we go. Okay, much better. Now we can see what's going on here. Okay, so let's take a look at the first one. Measure of angle CAF. Okay, CAF, this angle right here. Okay, so if you notice, I'm going 0, 10, 20, 30, all the way here. CAF would looks like it'd be, what, 130 degrees? That one was kind of easy enough, wasn't it? Okay. EAB. EAB, this angle right here. Okay. So I want you to think about this angle. I know that the whole thing here is going to be 90 degrees, right? Okay. I know that's all 90 degrees. And I also know that this piece here is 20 degrees. So that would be 90 minus 20. So that should just be 70 degrees. Okay. Angle GAB. Let me get my eraser again so I can clean up some of this mess. Okay. Angle GAB. GAB. Okay. So we know, again, the whole thing from here to here looks like it would be 140. And we're going to subtract off this 20. So that would give me 120 degrees. And then we have also angle HAD. HAD. Okay, so I know from here to here is 90. Now, I need to figure out how far is it from here to here. Well, that's 10, 20, 30. So 90 plus 30 would be 120, right? And we found the measure of each of our angles. Okay, so let's see if we can do this next part. All right, so it says complete parts A and B, perform the following operations. Okay, so let's see if we can do part A. So we have 18 degrees, 24 minutes, 39 seconds, and we are going to add 13 degrees, 48 minutes, and 38 seconds, okay? So, Ken, let's start adding. So let me grab my calculator right here. What's 39 plus 38? 39 plus 38 is 77, right? 77 seconds, okay? But guys, isn't 77 seconds the same thing as 1 minute and 17 seconds? So I'm going to keep that 17 right here, and I'm going to carry my 1 over here, okay? Now, I'm going to add 24 minutes plus that 1 minute that we're carrying over plus 48 minutes. Okay? And that's giving me 73 minutes. So 73 minutes. Isn't that the same thing as 1 degree and 13 minutes? So I'm going to keep my 13 minutes right here, and I'm going to carry that 1 right there. And I'm going to get my calculator, and I'm going to carry the 1 plus now the 18 plus now the 13, and this is 32 degrees, okay? All right, so let's do the next one. Let me just kind of clean up some of that mess. And we have, what is it, 11 minutes, 23 seconds minus 6 minutes and 44 seconds, okay? So 11 degrees, 23 minutes, minus 6 degrees, 44 minutes. Okay, so I'm going to borrow 1 from here. That's going to become a 10. That 1 that I'm going to borrow is going to become 60 minutes, right? So think about this part right here, guys. 60 and 23. Think about that as 83 now, right? So I'm going to go 83 minus 44. It's giving me 39 minutes. And 10 minus 6 is 4 degrees. Okay. All right. So the next one here is 0.6 degrees. And it says express the following without decimals. Okay, so what I'm going to do, I'm going to convert this to minutes and seconds. So I'm going to multiply by 60 minutes. Okay. So 0.6 times 60 is giving me 36. So this is 36 minutes. Okay, that's for the first part. For the second part, the 17 we're okay with. It's 17.46 degrees. The 17 we're fine with because that's in degrees. What we're going to do is we're going to convert the 0.46 to minutes and seconds. So I'm going to take my calculator again, 0.46 times 60, okay, and that's going to give me 27.6 minutes. But I want to convert this 0.6 to seconds. Okay, so 0.6 times 60 is 36 seconds. Okay, so now we have 17 degrees, 27 minutes from this part right here, and 36 seconds. Okay. All right. So let's take a look at this next problem, see if we can't figure it out. And it says the measure of angle AOB is 1/9 the measure of angle COD. So let's do this one. Okay, so we know that the measure of angle AOB is 1/9 the measure of angle COD. Okay, so you can see that this angle right here is 1/9 of that angle right there. Okay, if they're calling this angle Y, then we could say that this angle is going to be 1/9 of angle Y. So that means that angle Y plus 1/9 of angle Y is going to be equal to, guys, this right here is what we call a straight angle. Straight angle is 180 degrees. Okay. So first thing I'm going to do, I'm going to see how we have a fraction right here. I'm going to think of everything as a fraction. And I'm going to say, look, between 1, 9, and 9, 9 is my common denominator. So I'm just going to multiply everything by 9. So 9 times y is 9y. 9 times 1 is 9 over that 9 that I already had there with my y. And 9 times 180, let me get my calculator, turn it on again. 180 times 9 is 1620. Okay, so this is 9y. 9 over 9 is 1y equals 1620. So 9y plus another y is at 10y equals 1620. So when I divide both sides by 10, I'm coming up with y is 162. Okay, so look at what angle y is. This angle right here is 162 degrees. That's a measure of angle COD. So this angle right here is going to be 162. If I wanted to find this angle, remember the whole thing is what, 180? So if I just take my calculator and say, well, what's 180 minus 162, I'm coming up with 18. So this angle right here is 18 degrees. That little piece right there, 18, right? Okay, let's scroll down un poquito. Okay, and let's see if we can figure this one out. It says the measure of angle AOB, so this angle right here, angle Y, is 35 less than 4 times the measure of this one. So that would be 4x minus 35. Okay. All right. Now this is a right angle, so that means that everything has to add up to 90 degrees. So angle Y, which is 4x minus 35, plus measure of angle X, has to add up to 90. So 4x and another x is a 5x, minus 35 is 90. So we can just add 35 to both sides. Okay. So this is going to give me 5x equals 125. And when I divide everything by 5, x is going to give me 25 degrees. Okay. So angle, let me see. So angle AOB, let me write it right here. angle AOB, AOB, and angle BOC. Okay. So BOC is X, which we just found to be 25 degrees. So the other one, we can say, what's 90 minus 25? And that should be 65 degrees. Okay. So we found them both. Okay. Whoa. Let's take a look at this next one. Angle BOC. Okay, let's see if we can do this one here. BOC. So B, O, and C. This angle right here. Okay. And angle AOB. AOB, let's see. Let me get a pen. Here we go. A, O, and B. Okay. All right. So, a couple things we're going to know. Remember, the whole thing here is going to be 180. So how many x's do we have? We have 4x plus 1, 2, 3, 4y is 180. First thing I'm going to do, guys, I'm going to make this a little bit easier by dividing them all by 4. So that's telling me that x plus y is, let me get my calculator, what's 180 divided by 4? 180 divided by 4 is 45, okay? So, if you look at, oops, let me get my eraser, sorry. If you look at the first thing we were asked to find, what's the measure of angle BOC? B-O-C. BOC is the same thing as x plus y. And we just found x plus y to be 45 degrees. So that goes there. Guys, when I did this problem over here, the AOB and the BOC, those were for these numbers there, okay? All right. And it says, explain why the exact values of x and y cannot be determined. It says the exact values of x and y cannot be determined because the figure only gives us enough information to find the sum, because we were adding. Let's see. To find x and y, more information about the relationship between x and y or values such as x or y would be required. Okay. All right. So now, in the next problem I have here, it says, describe the size of the angles of the pieces of a circular pizza if the pizza is cut into equal slices in the following number of pieces. Okay, so we take our pizza, right? Part A says we're going to cut it up into 4 pieces. 1, 2, 3, 4. Okay, so we're looking for these angles here. So wouldn't those angles each be 90 degrees? Okay. And again, how did I do that? Think about it this way, guys. Remember, the whole circle is 360. If we take 360 and divide it by 4, we get 90. Okay. So now, let me erase this. And let's do part B. Okay. So part B says we're going to take our pizza and we're going to cut it up into 6 equal pieces. Okay, there's my 6 equal pieces. So we're going to take 360, we're going to divide it by 6, and that's going to give me 60 degrees. So for part B, 60 degrees. Okay, so guys, instead of me drawing a pizza and cutting it up into 18 circles, for part C, aren't I just going to take 360 and divide it by 18? So 360 and dividing it by 18 and 20 degrees. So this is for part C. And then for part D, again, what have we been doing each time? Taking 360 and dividing by the number of pieces. And I'm going to put it like this with a little degree sign there, right? All right. So it says the protractor in figure 2 shows the measures from 0 to 180, but by definition of an angle, there's no reason to limit the measure of the angle. We refer to an angle as ABC in figure 3, there it is. And we typically mean the smaller of the two angles, but we could also refer to the larger angle. We could also talk about this angle right here. And the larger one is one whose measure is greater than 180, but less than 360. And that's what we call a reflex angle, okay? And observe that the measure of angle 1 plus the measure of angle 2 is going to add up to 360. So it says to measure a reflex angle, a circular protractor, as in figure 4, is sometimes used. Instead of being marked from 0 to 360, this model is marked from 0 to 90 in quarters, okay? Alrighty. So it says use a protractor to find the measure of angle parts A through D. Okay, so angle DAC. DAC, this angle, let me get my red pen, this angle right here. Okay, so that's 10, that's 20, that's 30, that's 40, and looks like it's about 45 degrees, okay? Okay. Angle DAE. So DAE. Angle DAE is going to be here, here, and there. Okay, so I know that from here to here is 90 degrees. 90 plus 10 plus 20 plus 30 plus 40 plus another, it looks like 4 degrees here. I'm trying to see. It looks like 4 degrees. So 90 plus, what did I say? 10, 20, 30, 44. 4 degrees would be 134 degrees. Okay. Guys, when you're doing this on my math lab, you should be able to see the picture much clearer than I am. Okay. Angle CAF. CAF. Okay, so let me get my blue pen, or let's go with black. CAF. Okay. So again, I already know that from here to here is 90 degrees, so I'm just going to count 10, 20, 30, 40, 1, 2, 3, 4. I'm counting 4 again. So again, that looks like to be also 134. And then it says the measure of the reflex angle for BAF. Okay, so let me erase a lot of this mess that we got here, and let's find a reflex angle for BAF. Okay. So angle BAF. The reflex angle, so the measure of angle BAF would be this part right here, okay? So again, I already know that from here to here is 90. So I'm going to count 90 plus 10, 20, 30, 40, 50, 60, 70. So 90 degrees plus 70 degrees would be 160. The reflex angle says take 360 minus that number, and I'm coming up with 200 degrees. Okay. And that would be my reflex angle. And that right there, guys, was 11.1. It's a long section, isn't it? 53 minutes.